measures actual usage of the Python language. And I don't know if you can see this, but this column here is of particular interest. Python is the number one language. It's been the number one language for over a year, actually several years. But in this index, it shows the percentage of users that use Python, or the percentage of the overall use. Out of 100%, Python has 26%. Now, in case you're thinking that seems like not very much, the second place language, C++, which, by the way, is what they use to create Mac OS. They use it to create Windows, Microsoft Word. So some big deal kind of stuff. Is 9%. So the first place is 26%. Second place is 9, 9, 8, 5, 3. And it just goes on in this long tail of 1% down below that. So Python is huge. And not only that, in the last year, it is plus 8%. So not only is it really popular, but it's still getting more popular. And if you look at this headline, the headline for August is AI code assistants boost Python even further. So Python usage is skyrocketing, mostly due to its connection with AI. My son, who worked at Microsoft, programmed AI for Microsoft. He did not use a Microsoft language for that. He used Python working at Microsoft. So there's a lot there. If you look at this graph of programming languages, this line right here is Python. And you'll see Python up here, and the next 9 of the top languages are all down here. So you're learning a great, really useful, really practical language that also happens to be extremely popular. What that means is, when you go out looking for a job, if you want to be a programmer, being great at Python is an advantage. So where is Python actually used? A few companies use Python. You might recognize a few of these. These are all companies that use Python code in production situations, which means when you're using their product, they are using Python. In somewhere in their ecosystem, they have Python code that's actively used. So it's a big deal, really useful. What kinds of things can you do with Python? Web development, data science, machine learning, artificial intelligence. Maybe you've heard of this. Robotics, game development, scientific computing, databases, embedded systems, and Internet of Things. And that's just the tip of the iceberg. All kinds of things can be done with Python. Now, I want to take a second and help you understand how Python programs work. Because Python is what we call a high-level language. And in the world of computer programming, that means something. Now, a high-level language sort of has the sound of something that's like better or more advanced or somehow superior, right? When we say I'm a high-level hockey player, that would mean I was like pretty good at it, you would think. But it doesn't really have anything to do with how good Python is. It's how it interacts with the computer. You see, a low-level language like C or C++ or even Java, actually not Java, C or C++, actually gets what we call compiled. So I write a program in C++, I compile that program, which means it takes the language that I write it in, and it turns it into language the computer speaks natively. And then that program, when I run it, talks directly to the computer. Okay? Python, and that's a low-level language. Python, being a high-level language, is also can be called what we would refer to as an interpreted language. And so what Python does is it doesn't get compiled. When I write a Python program and I run that program, it actually talks to the Python interpreter. Okay? And that Python interpreter talks back and forth to the computer in its natural language, and then it spits out a result. that I can see. And the reason that that's important is because an interpreter is useful because it allows us to talk another language. It allows my Python program to speak to the computer. That's useful. But if I was using an interpreter here in Spanish or in the class, let's say I was translating the whole class to Spanish. So I would say something in English, and then the interpreter would say something in Spanish that represented what I said so that presumably the class could understand it. And then the class would say something back to the interpreter, and the interpreter would say it back in English to me. How is that different? In what critical way is that different than me just speaking to you in English and you understanding me? There's another step there. And what does that extra step do? But what does it do to the rate at which I can speak?
It slows it down.
It slows it down. Because I have to pause. No, that was a good answer. I have to pause for the translator to do its work, and then they translate it back to me. It slows everything down. So while it might be easier than me learning Spanish, which would be the equivalent of a compiled or low-level program, a high-level program being interpreted has the end effect of slowing it down. So the big trade-off, Python is easy to learn, it's fewer steps, it's easier to develop with. There's a lot of great things that come with not having to compile your work before you run it. The trade-off is speed. Now, am I saying that Python is slow? You won't notice it. With your human mind, you won't be able to tell the difference between how fast a Python program runs and how fast a compiled C++ program runs. However, you have to keep in mind that a lot of these companies that are using Python, like Google, won't use Python in a production outward-facing format where they are having, 100,000 users run that program every second, because at that scale, the difference in speed between an interpreted program and a compiled program can actually cost them thousands and thousands of dollars a day in energy cost, not just in speed, but in energy cost. So it's not Python running on your computer being a little bit slower that's problematic. It's Python running on a machine that is interacting with hundreds of thousands of users. At that scale, with that many people running that program, the speed of that program slows it down enough and requires more computing power because of the translation, enough that it makes a big difference in finances, in even environmental factors. I don't know if you've read anything recently, but one of the big criticisms of the power that it takes to train AI models is in how much water consumption is used to keep the machines cool enough as they compute, as they train those machines to put out the next version of ChatGPT or whatever. So at that scale, it makes a difference. At our scale in this class, you won't notice a difference. Everything is going to seem too fast for you. And in fact, in some of our programs later in the class, we'll actually build in lines of code that cause the program to slow down because it would run too quickly otherwise. One of those examples is the video game assignment. The video game assignment, we're going to have to actually slow it down because if I run a video game on my computer at native speed, the game will be over before I can even move my character on screen because it will spin through so many cycles that quickly. So we actually build a clock in there to say pause, slow this down, wait, so that it can be a playable speed game. So Python programs run. High-level language means it's interpreted, means it runs a little slower, but we don't have to worry about that. Now, if you go to work at Google and you have a choice between Python and another language, that's where the choice comes in. But short of that, you'll probably be okay.